Hey guys, welcome back. I'm Malav Doshi and you're watching Malav Doshi DGDKT, and today I'm gonna explain you the Euclid's division lemma and algorithm to find the HCF. But before I start explaining Euclid's division lemma and algorithm, first of all you need to learn long division method and HCF. Now HCF, I assume that you might be knowing that it's highest common factor, that the highest factor which divides both of the three of them, all the number that is given. Now long division method, it is the method of finding HCF. I might upload, I'm not sure, I may upload the proof of this method, I am not sure, but I may. So first of all, let's learn what is long division method. You might be knowing the prime factorization method. For example, if I take HCF of 72 and 48, let's start with simple one. Now by prime factorization it would be very long. So now if you know this method and want to directly learn Euclid's division lemma and algorithm, go in description, the time is mentioned that when the division lemma starts. Now let's see. So first of all, what you have to do, identify the smallest number between these two, 3, 4, 5, like that. Identify the smallest number. Here it is 48. Okay, now it is 72. Now just divide it as it is, as you do simple division. So here it would be 48 ones are 48 and the remainder would be 24. Okay, now what you have to do, make another box like this and write this one, this digit divisor again. It is 48, right? Now do simple division between these two. So it is 48, it came 0. So now at this stage, when the remainder comes 0, the divisor of it is HCF. It is the HCF, yes. So 24 is HCF. Now if you want, you can confirm. Let's do it by prime factorization method. That is 236, 218, 29, 33 and 31. Now let's do a 48. It is 224, 212, 26, 23 and 31. So let's take out common. Okay, so 2 into 2 into 2 into 3, so 2 cube into 3, it is the HCF. Okay, it is 24. So here it is the long division method. Now let me show you in 3 digits that how you can see means long division. Let's do this. Now let's take 3 digits. Let me take, okay, add 72, 48 and let me take 36. Okay, now here what you have to do, identify the least digit, then the second most least digit, means you have to arrange in ascending order, and the first two you have to take. So ascending order here would be 36, 48 and 72. So you have to first of all take the HCF of 36 and 48. So now let's take it. So here we write 36, here we write 48. So here 1, 12, again 36. So 12 is the HCF of both 48 and 36. Now you have to divide this number by the HCF of this both. Okay, so 72, 12, okay, here it divides directly. So 12 is HCF of, means whole 3. So let me just revise this whole method. What you have to do, it's very simple. In case of 2 digits, you have to just take the smaller one and divide the greater one. Sorry. You have to take the smaller one and divide the greater one using the smaller one, and then the remainder at the first stage you have to take it as divisor and make the first divisor as a dividend. Okay, and at the stage when the remainder comes 0, that divisor is your HCF. Now this I am making you learn because it would help in understanding the concept of Euclid's division algorithm. Algorithm is nothing but the statement form of this. I'll show you how. In 3 digits or digits more than 2, you have to arrange the digits in ascending order. Then take the first 2 digits, take out the HCF, then divide that HCF with the third digit, then of that both. And if it is 4 digits, okay, if it is 4 digits, 6 digits, then what you have to do? For example, I have here 72, 48, 36 and 24. Okay, so now what you have to do? Take HCF of this both, 24 and 36. Take HCF of this both. Okay, let's do 48, 72. Oh, we took it out. It's 24. Okay, now of 24 and 36. It's 12. Okay, then what you have to do? Divide the HCF of both. It would be very simple. You can do individually if you want. You can follow this method here also. Take HCF of this 2, then divide 48 by this 2's HCF, and divide 72 by this, by HCF of this and this. It would be very confusing, right? So you have to do nothing. Make 2 fragments. Take HCF of this 2 and take HCF of this 2, and then divide them. So here you got 12 as HCF, final HCF. Okay, so this is it. This is the method. You can follow it, and it would be not that much asked, but I just gave you the information about 4 digits. At max 4 digits would be asked. In general, then God knows. Division lemma is nothing but the basic division theorem. That is, it's not the basic division theorem, but it's a shortened form of basic division theorem. That is, dividend is equal to divisor into quotient plus remainder. Now what it states, it formulates this for any 2 integers. What it states, that if 2 integers are there, that is a and b, it could be means what we can say, that it could be expressed in the form of a is equal to bq plus r, where a is greater than b. Okay, and here is the one condition, that r can be greater than or equal to 0, but it is always less than b. Why? I'll show you with the practical example why. Now here let's take 72 and 12. Okay, 72 and 12. Now you do not have to divide like this in exam, but I am just showing you the derivation and just clearing your concept. Okay, now here what you can see, let's take it as 73. Okay, let's take it as 73. Now here 12 into 6, 72 here. Now here what you see, that 73 can be expressed as 12 into 6 plus 1. So here it is a equals bq plus r, and here notice one thing, r is less than 1. Now why it has to be less than 1, I'll show you. Now let's take same example, 73 into 12. Now here we took 12 6 is 72. I am here now taking 12 5 is 60. Okay, 13. It comes 13. Okay, now what will happen here, just see that now what I have to do, I have to divide it again. So it is not, it is the misconception or it is the violation of division law that you cannot take the remainder anywhere greater than this digit. If you will consider 13 as remainder, then it would be the violation of the law, because you can divide 13 further, but you can divide 13 in the first step itself. So for this reason, the remainder has to be always less than the divisor. Okay, so the theorem states that for any two integers a and b, there exist two integers q and r satisfying this thing. Means what I just told, that any integer a can be expressed in the form of multiple of any other integer plus the remaining part of it. This is the remaining part. If a is an integer which is not a multiple of b, and there would be something you have to add into b into q to make this integer. If it is a multiple, then r would become 0. Okay, so here it is that a is getting divided by b. Here it it's right, b into q. Here it is something like p or anything, and remainder is coming r. So you can write a equals bq plus r. Okay, this is it, nothing much. Euclid's division lemma is nothing much. It is just saying that if there are two integers, then and if one integer is greater than another, then it could be expressed in the form of a is equal to bq plus r. Okay, now let's move on to Euclid's division algorithm. Here you would get help with this long division method that I showed you. Now here, what is the Euclid's division algorithm? It says that if you have to find HCF of a and b. Okay, so what you have to do, first of all, write like this: a is equal to bq plus r. Now what you have to do is take b as dividend, means take b here and express it in the form of rq1 plus r, and get it continue until you get r equals 0. Now are you getting something? Can you compare this thing with something? Let's take the HCF of this example only, 72 and 48. Okay, let's take. So here we have 72 and 48. This one is less than 72. So 72 equals 48 into 1. Okay, plus 24. Okay, am I right? Now here it is 24. Now what you have to do, take this 48 as a dividend. Now it is 24 into 2. Therefore this 24 is HCF, because you are getting remainder as 0. So here you notice something, that what we did here, we in long division method we did two steps, right? 24, 48. Okay, now you do nothing. Write this first division in the form of the division, means what we can say, the division rule, that is 72 equals 48 into 1 plus 24. Then write the second division, this one, this division. You write this one, now write second one, that is 48 equals 24 into 2 plus 0. You can see this both are same. So in short, Euclid's division algorithm for finding HCF is nothing but the statement form of the long division method. Okay, so now let me revise everything in just a minute. That is, first of all, long division method. In long division method, what you have to do, if it is two numbers, then take the greater number as dividend, smaller number as divisor, divide it, and when the remainder comes, take that remainder as divisor and the previous divisor as a dividend. Continue the cycle until you get the remainder 0. Once you get the remainder 0, then the divisor is the HCF. Numbers, arrange the numbers in ascending order, then take the first two and write the greater one as a dividend, smaller one as divisor. Continue that cycle up to you get the HCF of that two number. Then divide the third number by the HCF and then also continue the cycle till you get the HCF. For 4 numbers it's not really necessary. Then also I am showing you that take two numbers different, then two numbers different, take the HCF of both differently, divide the both HCF until you get the remainder of both HCF 0, then the final one would be your HCF. Now, Euclid's division lemma is the shortened form of this basic division theorem. That is, if there are any two integers, then bigger integer can be expressed in the form of multiple, the nearest multiple of the smaller integer plus the remaining part, or a is equal to b cube plus r. But there is a condition that this remainder, or r, should be greater than or equal to 0, and it should be always less than b, or this integer. Okay, this I have shown you. Now, this Euclid's division algorithm is just the statement form of the long division method. What you have to do is just write a is equal to b cube plus r, then going on taking b as this main number and r here, r q1 plus r. Okay, so hope you like this video. Then if you have any doubts in comment section, if you have any doubts, then mention it in comment section, and welcome back in my channel, and stay updated, subscribe my channel and press the bell icon. Please like it. Thank you.